SplittableParDo. DoFns. I always say it wrong. So it's splittable DoFns. I'm Alex. I'm the big data architect of the same company as Wout works on. And I'm also a Google developer expert in my nightlife, so I don't have life actually. No need again. It's full of meetings anyway. The last I checked, so I'm quite fine being here without any meetings. So what I already explained with like our new platform, everybody is pushing their entities, and it's quite a pain because like certainly if you have like a bulk update that you want to do in a Mongo collection. Like change thousands of documents, they have to read it all out, push it on PubSub. It's really a pain. And then Mongo 3.6 came out with a nice feature called changestreams, and we said, let's look at that because maybe it could like ease the development of a new microservice or a new feature or new contracts. So go into this. And so, okay, what do you have to do? Let's see if there is like an I/O from Mongo, and there is, but not for the unbounded source. So the unbounded means like a stream, and a change stream is by definition a stream. So, okay, let's contribute. We thought, that looks like interesting. And then we get a remark, don't look at the I/O connectors, there's something new like a splittable DoFns. And I said, yeah, it was maybe, I didn't know where to go to, and this made me look into splittable DoFns. So I was quite happy not to do the I/O stuff. But of course, splittable DoFns is like something new, and you have to learn it. And people that work with Beam know documentation is not always that fun. So the best thing to start with is the blog post. It's like now a year old. You'll get the slides. It's a link. It's the best way to start with the concepts, how it works. It certainly also has a link to the design doc. But the hidden gems are in the Java doc and experiments that you have to do. First, let's check that all the runners that we need. We'll need a direct runner, and we're on Google, so the data flow runner does need to be there as well, and it supports it. So we were quite happy. But what is a SDF for short? Splittable DoFn. We first have to look at the DoFns itself. What can't it do? So, you know, a DoFn has like one input element. You do your magic and have like 0, 1, or multiple outputs. And that can be massively parallelized. But the work inside of your DoFn, it can't be parallelized. It's just a sequence of stuff that you do. And it also cannot produce like infinite output. It's not that you can have like a loop inside of your DoFn, just putting out output, 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 output. What if your DoFn will get rescheduled? Where in my loop was I? It's kind of very bad practice. I don't think it even probably works. The pipeline will probably freeze. So the DoFn, what does it add? It has a possibility to split the work, and that's done through restrictions. So if you have an input element, you, as the writer of the DoFn, can say, okay, for this element, I have this amount of blocks that I can define from 0 to 100 or something. You're in control there. And also a way of checkpointing. So if you have like amount of work to do, there are checkpoints that you have to take so that the runner can say, hey, stop your work, I'm going to reschedule you on another worker. Those are part of the API. It will get clear in an example. And by this checkpointing mechanism, you have the possibility to have like an infinite output stream. but it has superpowers. Because it's like any DoFn, it takes like an input element. And by having this principle that has an input element, it could read out from something else. So it means that it's composable. So you can write two different SDF, compose them together, and you have something completely new. Again, in the examples, you will see what this means. So an example, what you can think about is like a file on a storage, be it S3, Google Cloud Storage, whatever. You take a URL, and you as the SDF say, okay, I can split this up in from 0 till the file size. Okay, runner, now let's split it up. Another example is like big table, there where you do not work with integer as an input range. You can say you have a start key and an end key. That's my work that I want to do. And here is an example of what you could do with the composition of different kind of SDFs. So you could make like, sorry, it's the other button, yes. So you could do like make an SDF that's unbound, that reads like a storage bucket, and watches for changes on that storage bucket. And it outputs like URLs every time there's like a new file on that storage bucket. Then you can click in another SDF that you wrote that is bounded, that takes that URL, splits it up an amount of work of the file size. So you have now like an unbounded stream on a storage bucket. Could be a fun thing to write. So how does the API looks like? You start with taking like a normal DoFn, and you start with adding an annotation. It's optional, but like if you're a good citizen, you just indicate this class is like bounded per element, so you have a clear indication that's SDF. Then the first thing, instead of like doing the process per element, you say what the initial amount of work is. So, and you do that with writing a method with the get initial restriction. And then you can say the URL, for example, okay, it's the size, the amount of work that I have to do is from 0 till the file size. Another thing, but that's optional, is that, hey, okay, I have this amount of work. I know the first split would be like in 3 parts, 4 parts. How do you do that? But it's totally optional. You can have like some scenarios where that could be handy. So this is a totally bogus example, but that's how you would like do it. You get your initial restriction in, and you split it in 2. Generally, a very bad idea, but maybe you know best for your use case how to split your initial work. It's only called once, so you only have like only once a chance to say, okay, this is my range. I can split it up in different pieces. That was, for me, quite confusing. Should I here write my own splits constantly? No, it's only called once. And so your restriction is generally called it's defined by a range. Like in the example, offset range is one of the ranges that are out of the box supplied from 0 till size length, for example. It always comes with a tracker. And the tracker actually does all the housekeeping. You have the option to do that, to define or parameterize those things in your code, but it's also optional. But then the real work starts. So you've defined your initial restriction, in this case, again, a file. And you'll see, instead of the process element where you normally get just the context, you now get a tracker. The tracker is like your view on the world or the restriction you have. So the first thing you do is like, what is my restriction? What is the part of the block that I'm working on? And you get that through calling current restriction. And then it's up to you to claim part of that block that I'm going to work at. This doesn't need to be the first element, because, for example, if you have like an Avro file, it's been split in two, chances are high that the split doesn't split on the exact part where the block starts. The blocks start generally a bit after the split. So you have to try to find, and that's through the normal Avro API, where does my block start, and you then claim that position. And that's a gotcha, is that you can go past the block, because the restriction defines from X to Y, you can read past the Y. I hope this graph will make it clear. So again, let's take an example of the Avro file. It's different blocks. You cannot start in the middle of those blocks. So the first restriction is complete block. You do the claim. You say, I'm going to work on position 0. OK, do your work. Happy. OK, still work. Then Beam decides, OK, this is going too slow. I can split this up. You see already the splits are not aligned with your blocks inside. So how do you handle that? OK, the first runner just continues. Also notice that the first block doesn't disappear. It just keeps a view of the complete. Well, the restrictions is from 0 to 65. It doesn't stop it or reschedule it somewhere. It just keeps on going. And the other blocks try to claim blocks. OK, it starts to output. Again, let's go faster. The claims work. Still, and now the interesting thing is that, like, block 1 doesn't try to claim something that's in its range, but the runner says, no, you can't go on. That's the part where you actually stop work on this block. Why? Because actually the second block has already started working on those things. And the third block is at the end, so certainly it just doesn't need to continue. And again, then maybe that was not so clear. You see here at the second block, it doesn't need to stop at the end. Otherwise, this block of data will not be read. It just falls all into place, so you can just go on till the next claim, and that's here, and your tracker will say, OK, now you can't go on. So that's the clue, is to do all your stuff on the try claim. I try to claim this block. And then you can go on till the tracker says, no, stop with it. Well, that's there's a link to GitHub where you can play with all those things. Now for the unbounded thing, so with the infinite streams. It's very similar, but it brings something new. And how do you do that? With the offset range, the standard way to go. So if you can divide your work in integer blocks, go for the offset trackers. And there you say, OK, I go from the beginning till the max value of long. And that's an indication that actually you will never reach the end. And then the second part of the API is something to return to do the flow control. Remember that I said, like, you have something to say, to have some checkpointing, and this is the way. So normally with bounded, if the try claim fails, you just return. But in an unbounded collection, you return a stop element. So you know that the work has stopped. But you can do some other stuff, and that's resuming. So it could be in an unbounded collection that your runner said, OK, here is a position to work on. And you know, I don't have anything yet. let's come back in 100 milliseconds. Maybe I have something. And that's a way to actually give feedback to the runner to say, OK, let's go faster, let's go slower. A gotcha, what I also noticed while trying those things out is that resuming has a different effect when you've claimed or when you didn't claim. So it's very important that if you do a try claim on a block, make sure that you can finish it, because you will never get a chance again to work on that block. So if you're not sure that you can finish it, make sure not just say resume and come back later. It will call you again later with the same restriction. If you tried a claim, the position will be the next up. That's a gotcha. So how does it look in a nice Google slide graphic? Again, you start with the beginning, position 1000, because in general, you never start at the beginning. Do your work, again, do your work, again, okay. You try a claim again, and the runner says, well, I'll need to reschedule you somewhere, so the claim will fail. Then at this time, you return a stop. Say, I'm stop, I'm done with it. And okay, your DoFn stops your instance. It will get a new one with a new claim on the new position. You claim, you do some work again, and here's again a point. Okay, goes fine. Okay, stop. The claim fails again, so it's time to stop again. The first part, the left part, is just while looping. So you take checkpoints somewhere and do not claim everything, because you could do those things in a loop. This time, this is actually kind of a new example where you actually handle each element separately. So that's why I have the thing here, where you're going to use the resume. So you claim the block. Again, you do your work. You stop. And now you say, OK, I will not have work on this block anymore, but I know there will be no work anymore in the next 100 milliseconds. You stop your DoFn. You have like, say, and come back in 100 milliseconds. OK, voila, it stops. There will be a new call to process element with the next block. OK, you do a claim. Now say, you know, damn, I don't have work anymore now. Then you can say now, let's resume and come back later. Then the next step, the next time, it will come back with the same restriction. So it goes on and on and on. And that's a way where you can control how the flows goes for infinite. I have a nice example with that link, and I'm going to, if I have some time, show you. And that's a second sticker. So it's like there's something in the Beam SDK where like every second there is like a tick or something. I've rewritten that in a few lines of code in a splittable DoFn with that flow control. Gonna go to IDE. Voila. Demo pipeline. Second stick. Is that big enough? Probably not. I should have made that bigger. There's like a trick for it. I forgot.
Command-Shift-A and increase.
What was it?
Command-Shift-A, then type the word increase.
Oh. Sorry. Yeah.
You can do view presentation mode.
I'm going to do that. If I find it. Voila. Sorry about that. So this is DoFn, a delay for something in. See here the. Does it work? No. So here we do claim the block. we know we output some stuff. Okay, so this is to see, am I in the current block for a tick? And if I'm not, I'll just stop and claim and resume. Sorry. Okay. The stop is just there if you get a stop to stop. But if you fall through the loop, you just wait for the next second or number of seconds. Let's run this. Sorry, gonna get out of this. Okay. I should have prepared this part. And you're gonna take the tick just to show that it works. You can run this. So the example is just runnable normally, I hope. So now I've put it on every 5 seconds and it outputs something. 5 seconds, voila. So it's also possible with the DoFn. And it's not a lot of code. You see a few utility functions, but it's for extra logging. But our original problem was like to have like a Mongo change stream. So what happened with that? Actually, it kind of failed. Well, it's running, it works, but I'm not saying that it's production ready. Why not? We're using Mongo 3.6. And the API for Mongo has no possibility to actually do checkpointing itself. So you can do like start looking at a collection, and you have like a resume token. But it's like, if you work with a resume token, you have like state management. And that's not what Beam is all about. Beam is going forward, and that tracker has like tries to divide some work. So it's kind of a failure, and we're waiting on the putting live on the 4.0 that has possibility to say, I want to read from this timestamp to this timestamp. And then we can translate our work that we want to do again in an offsite range. Because the one that's now running in a test mode is like just continuing and just with a tick read what's there, But you can imagine if that stops and you have to try again and you don't have that checkpoint, you lose part of the data. So sorry to disappoint you guys about this part, but yeah, not everything is like nice and shiny. But the Beam API is like nice and shiny, but not the Mongo part. So remember, things are composable. If you want, you can do nifty tricks with that. And if you can do things like with the offset range, it's just a bunch of numbers. Look at that one. And that's the link to the demo. But the slides will be probably posted, I don't know how. So any questions? Answers I have to provide.
I was going to ask, rather than MongoDB, can you try other backend? I was thinking data store or anything that can support that, at least to test with an external backend.
I don't know in my head that the API will be able to do that. I don't know. We're not using that currently, but don't know. Sorry.
No problem. Thank you.